Good evening, everybody, and welcome to another World Robot Olympiad webinar. My name is Duncan, and I will be taking you through the in-house this evening. I am the RoboMission head judge for the World Robot Olympiad here in South Africa, but both internationally as well. And with us this evening, we have Mr. Johan Bernardi, who is our Future Engineers expert. Not only that, he is the Future Engineers head judge internationally as well, and has been involved in writing the rules and preparing the competition. So if you are interested in Future Engineers, he is the man for you. So Johan, we're going to start with Future Engineers this evening. Johan, over to you. You are welcome to share your presentation and we can get going. While we wait for Johan, if you have any questions, you are welcome to ask them in the chat. Just type them into our chat there, otherwise the Q&A. At the end of the session, we'll have a Q&A as well, where we will answer all of your questions that have been typed into the chat. So at any point, if you have a question, feel free to type it into the chat. And if you do not feel like typing it, don't worry, we will open up the microphones for everybody right at the end so you can ask your questions that way as well. Now, I am at home. I think Johan is also at home. I know Dani is at home as well. Dani, our national organizer. And you may hear funny noises and things in the background from us. From me, most probably, I have my two little girls here with me running around. It's my 2-year-old's birthday, so she is hyped up on sugar and crazy things. So you may hear her in the background. I can see Johan's presentation. I think we are all ready to go. Over to you, Johan.
Thank you, Duncan. I have got just a couple of slides. And tonight is only going to be an introduction into WRO. So we're going to start slowly, and then we're going to start picking up with the next presentations. So let's get going. So the purpose of tonight is going to be the webinar. It's all about to introduce the Future Engineers category. Then we're going to look at how the challenge works. We're going to look at how to start competing. What do you need? How are you going to put it together? And then we're going to look at some practical advice that I have experienced over the years, different competitions that I've been judging, being involved with locally as well as overseas. So we're going to have a look at that. But let's start off by looking at what is Future Engineers. A couple of years ago when we started, we had a transition from advanced robotics category into the Future Engineers. There was a couple of things that we were looking at. And we had to come up with a theme at the time. And the people decided that we're going to look at autonomous self-driving cars, which is an engineering challenge. So in other words, our whole approach is to design a car that is self-driving. Teams are going to be building their own vehicle. They're going to design it, they're going to build it, they're going to put it together, they're going to test it and make sure that it adheres to the rules, and they're going to attempt the challenges as well. Now, when we do this competition, we would like all our participants to focus on the engineering process. It's not just about the robotic side of it, but it's the engineering process. In other words, from an idea, how do I put that idea into something physical, and so that it can participate within the competitions as well. So what we've also been doing is to say, well, students that are participating in the Future Engineers have been participating, hopefully or possibly, in the previous year's categories. When I started with the WRO, we had the primary school competition, and then we had the high school competition, and then it deviated a little bit, and then we had the advanced robotics category. Now, in all those categories, we had a specific kit that you were supposed to be using. And we felt that that is limiting the possibilities of what you can do with robotics. And we decided that we're going to make it open. So we're going to open up the hardware, we're going to open up the software, and you can use whatever hardware you would like to use. The same with the software. You can program in any language that you would like to program. In other words, you can do Python, you can do C, C++, you can do ROS, the robot operating system. So whatever is your favor, you can use. On the hardware side, you can use anything. However, there are some limitations on the vehicle, the autonomous vehicle, that you need to adhere to. Like for instance, the driving of the vehicle can only happen with one motor. So you cannot put a motor onto each wheel to make it drive. So you cannot use differential um, steering within the robot. So we decided to make it open. Now, why does this category exist? It exists for a number of reasons. It's simply because we would like to encourage real engineering thinking. So most of the people that participate in the future engineers are people that aspire to become an engineer one day. So the whole approach is to say, well, let's put you into a situation where you can experience a little bit of that engineering. What does the engineer think about when he develops these kind of things? We would like to expose the participants or the students to autonomous systems. It's not just about autonomous vehicles, but the concept of autonomous vehicles can be applied on any other system as well. We use the same controllers, we use the same actuators, we use the same level of programming. So it's not just for autonomous vehicles, but we can apply it onto any autonomous system. Part of what we would like to do is to promote designing, testing, and there's a difference to the other categories is that we ask the people to prepare a document that goes along with it. It's very much similar to the open category where you have to do a presentation and you need to prepare documentation. But here, the documentation is not just a document that you're going to prepare. It is you've got to keep track of your different revisions of the software that you've built and put together and what you've tested. And this is where we expose or not expose, we introduce them to the GitHub environment, which is a system that real engineers are using to keep track of what they've programmed, the documentation, the different versions that's been created. So we would like to expose them to that as well. The other thing that happens with future engineers is it's a team of students working together. So we emphasize the teamwork that needs to be development. Um, then also, you're not just going to develop your team skills, but there's a lot of project management skills that you need to apply as well. Not just apply it, but that you need to enforce. Um, one of the things that I can say is that in the future engineers category, your robot must be finished at least a month before the competition so that you can take another 2 weeks to fine tune what you've put together. Then after that, you take another 2 weeks to finalize everything so that when you arrive at the competition, everything is working. And I'll share a little bit of that a little bit later. So you need to gauge your different stages of your project and put that together as well. Now, the challenge itself, what is the challenge all about? We've already said that the teams must build an autonomous vehicle. It must be driving on its own. Um, the vehicle must complete a number of laps on a racetrack. The configuration of the track is going to change every time or every round of the competition. Now, there's a big difference between a lap and a round. A lap is where the vehicle travels around the track and do a number of laps. But a round is different participating, um, let's call it events at the competition. In other words, we've got 2 rounds in the open challenge and we've got 2 rounds in the obstacle challenge. So that's what we mean by the track configuration is changing every round. So every time that you do it for the second time, the outlay is going to change. So we will talk about that a little bit later as well. The vehicle, the objective of the challenge is that the vehicle must react to the environment and it must do that autonomously. It must make its own decisions on how to negotiate the um, the obstacles in that environment. There are 2 main challenges. The first challenge is what we call the open challenge, and this is all about navigation and stability. In the past, we used the open challenge as a kind of qualifying round. However, we found that not all the teams can actually do this activity. So they were eliminated automatically for the obstacle challenge. And we decided, no, let all the teams participate in the open challenge as well as in the obstacle challenge. Open challenge, navigation and stability. So you've got to program your robot, make sure that it can travel around the track in a stable way. And I'll talk about the stability a little bit later. The obstacle challenge is where we've got green and red objects on the track. Now, a red object is therefore a red traffic light. Green one simulates or represents a green traffic light. The red one, you've got to pass on a specific side. The green one, you have to pass on the other side. So we'll look at that as well. Now, in both of these, you have to do 3 laps. What we've changed the rules for this year is that last year, when you attempted the parking, your robot could start, you could switch on your robot in the starting section, and without that robot being moved, you automatically got the points for the parking side or attempting the parking. This year we've changed it is to say, well, you have to complete at least 1 lap around the track in order to qualify for the bonus points. Right, parking. We've introduced the parking about 2 years ago. The parking is still going to be there. In this competition, the parking is required at the end of the obstacle challenge. So you need to travel around the track, avoid the green and the red traffic lights. You're not supposed to bump into them, but you need to pass them on the correct side. But then once you've completed the 3 laps, you need to park your robot into a parking spot. And you need to apply parallel parking to be able to do that. Now, the open challenge, I've already mentioned that there are 3 traps. And the nice thing about the open challenge is that the track width can change. We do a randomization, and within the randomization, we choose a specific layout for the track. Now, the track could be, the width could be the same all around. It could be wide or it could be narrow, or it could be wide on the one side and narrow on the other side. And also, the other thing that we randomize is the starting position. So you can start anywhere around the court in the designated starting position. So that is also randomized. The focus on this challenge is that it must be a stable navigation that is being applied. And the reason why we say it must be stable is that the vehicle is not supposed to hit the outer walls. The moment the vehicle touches the outer walls, that's going to be the end of that that round. And then you need to participate in the next round. The obstacle challenge is where we've got traffic signs that have been placed on the track. A red sign, red traffic light, you need to pass on the right-hand side. A green traffic light is where you need to pass on the left-hand side. The vehicle must interpret the colors of the traffic lights correctly, and they must react accordingly. If you pass a traffic light on the incorrect side, you could lose some points. If you pass it on the right-hand side, it means that you continue into the next section of the track. The parallel parking task is after the 3 laps. I've already mentioned that the vehicle must park, and the parking location is defined at the starting section. So in other words, at the end of your 3 laps, you can end in the same section, and the parking area will be in that section as well. Now, the parking section will give participating teams additional points. So in other words, you need to have a good logic to park your robot. To get it in, there are 2 sides to the parking area, and you're not supposed to touch those 2 sides. Those 2 walls on either side of the parking represents another vehicle that's already parked over there. So if you drive into that vehicle, that means, causing an accident, which is something you are not supposed to be doing. I've already mentioned the randomization in the competition. What do we randomize? The first thing is the direction of the driving. In other words, the direction could either be clockwise or it could be counterclockwise. And remember, we're talking about autonomous vehicles. The vehicle must figure out by itself, does it need to go clockwise or does it need to go counterclockwise. There are some indicators on the track, but we will discuss that in a next webinar. The starting position can also change. There are 4 different areas in which the robot can start, and inside those 4 areas, there's different positions that the robot can start in as well. And then the obstacle placement can change as well. And here we're talking about the obstacle challenge. So the location of the red and the green traffic lights are randomized as well. And the number of traffic lights is randomized as well. Robots must adapt to the environment, whether it's the open challenge or whether it's the obstacle challenge, they must adapt autonomously to that environment. Right, so let's talk about what do you need to do, or what do you need to put together in order to enter this competition? Well, the first thing that you will need is a vehicle platform or a robot platform. And this could be made up, as we said in some of the earlier slides, is it's an open source environment. So you could use anything from off-the-shelf remote control cars that you can buy. You can use Lego kits, modular robotics kits that you can put together. So it's open-ended, but you need a vehicle platform. That's the first step that you need. The second one is adding onto that vehicle platform, you will have to add some sensors. Sensors that will provide you with information about the environment so that you can perceive what is happening around the vehicle. And then that is fed into the controller. So that's the next thing that we need is a controller. Now, I was about to say a powerful controller, but there's been teams with entry-level controllers, and they were able to accomplish the task. It depends on how well you program the device and how you can optimize your software to get a good performance out of the robot. So we've got the vehicle platform, we add sensors onto that platform, and I've already mentioned just now that we need to create the software that is there to control the behavior of the robot. Behavior means that it needs to make decisions. How do we make decisions? Is we need information from the environment. What's going to provide that information? It's going to be the sensors. And then the last one is in the Future Engineers is that you will have to prepare your documentation. I will go into that a little bit in a moment. Right, the vehicle platform. You need to create a stable chassis design. Now, what do I mean by a stable chassis design? It's as you travel around the track, and I've seen this at so many competitions where teams are building a robot, a base design, a chassis, and then they start adding the battery onto it. They add the controller onto it, and then they add all the sensors onto it. And at some of the competitions, those robots became too top heavy. And as they go around the corner, some of them just completely fell over, or it became so heavy that some of the teams couldn't control the robot. So instead of turning left or turning right, the robots were just going straight. So the first thing is make sure that you've got a stable chassis design. The next one is that your steering system must be reliable. Again, if your robot is too heavy, your steering is going to be really, really difficult to control. So make sure that you can reliably steer your robot around the track. You've got to be able to turn left, you've got to be able to turn right. And if you do the parallel parking, it means that you need to reverse as well. And then you're going to need a stable steering system as well. Then your motor control must be really, really good. To control a motor is not always just a straightforward switch it on and switch it off, or switch it on, change the speed, and do a couple of things. But you need to have a strategy behind controlling your motors as well. The more control you have over your motors, the better your behavior of your robot is going to be. Think for yourself, if your robot starts or you press the button, it needs to start, and you put all the power onto the robot, that robot is not going to behave very well. It might, because you've got an inrush current that comes from the battery into the motors, it might steer the robot in the wrong direction. So maybe we should ramp up the speed. When we slow down, we get close to an obstacle, maybe we should slow down a little bit. So all of those things has got to do with your motor control. So you've got to think very clearly how you want to control your motor. And then your mechanical construction of your robot needs to be, well, put together as well. Make sure that the robot stays together when it goes around the track. I've seen so many robots over the years where they do one or two rounds and then all of a sudden the robot starts falling apart. And that's something that you don't want to happen with your robot. From here, we're going to go into the sensors that you might need for your robot. Typical sensors, you need to be able to see what's happening around your vehicle. You could use camera systems. There are a lot of entry-level camera systems that works perfectly. Then we've got teams that can afford to buy some expensive camera systems. Naturally, those camera systems have got a lot more functionalities that you could use, but either one of them will be working. Then there are teams that decided, well, we're not going to put a camera onto our robots. They are going to use some other sensors. They decide to use some ultrasonic sensors. Ultrasonic sensor is to detect if there's any obstacles in front or on either side of your robot. So I could use that to detect obstacles in front of my robot. So I can detect whether there's a red or a green traffic light. At that point in time, I wouldn't know what the color is. That's where I might need a camera system, but I can implement a color sensor as well. Through a color sensor, I can detect what is the color of the object in front of us. Then we can use an internal measurement unit as well. An IMU is a sensor that you can put onto your robot, and it includes various other sensors as well. Two of the other sensors is the one is a gyro sensor where we can detect the angle of rotation, and we've got an accelerometer where we can measure what is the rate of changing the angle, and we can use those to determine what is the direction our robot is traveling in, and if we need to take a turn a specific angle, we can use the gyro sensor as well. You could use wheel encoders as well to calculate how far your robot has driven before it needs to make a turn, turning left or turning right. That we can use the information from an ultrasonic sensor is to say, well, there's an opening on the left-hand side. Maybe I need to turn left. If I detect it on the right-hand side, if it's still closed on the right-hand side, then it's a guarantee that I need to turn left. So I can calculate how far I need to travel before I can make those turns as well. And then the teams that have been participating for a number of years are implementing some advanced sensors. A LiDAR sensor is a sensor that can give you a point cloud map of your environment. And if you analyze that point cloud, you can clearly see where the obstacles are within that environment. You can clearly see where are the boundaries, the inner wall of the track or the outer wall of the track, so you can identify exactly where those are. Software components, it's all about calculating the perception. That means understanding your environment. We can make decisions, and if we need to make decisions, then it means that we need to choose the correct behavior according to after we've analyzed all the data that comes in. And naturally, we need to control our robot, and this has got to do with all the steering and the speed control as well. And then navigation and parking logic. A very nice website that you could use to put together your strategy for parking is go to Wikipedia and search for parallel parking. It's amazing. They put a lot of mathematical equations and things that you can use to control your robot. And how does it actually work? We don't actually go through all those mathematical calculations when we do park our robots. Um, but it just makes sense when you go through that. Remember, for us as human beings, it's easier to perceive the environment and to park a vehicle. But now we need to transfer that to a little car. And that is not always that easy. That's where we have to use some mathematical calculations. The system architecture is we've got sensors, there's perception, there's a decision that needs to be made. We pass it on to the control side, and that's where the actuators actually implements the control. Now, each layer that we have there has got a specific responsibility. That architecture is also modular, and that helps to improve the reliability of our system as well. If you structure your architecture very clearly, it means that it's simpler to find where the mistakes in the program could be, where you've made the wrong decision. It's easier to find them. And the programs talk about debugging, finding all the bugs within your software. Now, the engineering journal, um, is where we would like the participants to document the engineering process. From step one to step last, what have they done? They need to show their design decisions and how did they test their robot? What were the results of the testing? We would like to see that in the documentation. Explain why did you choose a specific motor? Why did you choose a specific sensor? Um, what is your motivation behind that? And how did you put together the software to control those devices? Um, your documentation, your engineering journal, is an important part of the competition, and it adds to the scoring side as well. If you do a really good engineering journal, it means that you might outperform a team um, that have got a very good performing robot, but the documentation is not good. That's where you can overtake them. So it's not always in this competition about the best performing robot. We've had it last year where we've had at the international competition where a team with really good documentation went up the ladder by about 4 positions purely just because they had better documentation than the other teams. The GitHub repository is where you need to upload your code. And you need to make a number of uploads to the GitHub environment. Because that way we can see that it's not just before the competition that you've quickly created your code, but over a period of time you've developed and created your code. The repository must be made public as well. And the reason why we make it public is so that future teams that would like to participate in this category can go onto GitHub and they can see what other teams have done to participate in this competition. Um, I've just mentioned that the commitment history is there. It must show the development progress that's been taking place. Then to start off with your GitHub repository, you need to put a README file on there, and that explains the whole system architecture and how your GitHub repository has been put together. How the scoring works in the next webinars, we're going to go into a lot of detail with the side is the robot performance in the challenges. In other words, you're going to get scoring for every obstacle that you negotiate successfully, and that's going to count to the final scoring for the open challenge as well as for the obstacle challenge. The engineering evaluation is also being done, and both of these contribute to the final ranking of the teams. And naturally, when teams have got the same scoring, there's a whole set of rules that we then apply is to take who's going to be the next team in the list. Common mistakes that teams are making in this competition is um, hard coding solutions. Oh, I can spend a whole lot of time about that one. Is make sure that your solutions that you're trying to code is it works, and that's why I've said previously that make sure that your robot is complete and finished about a month before the competition, because then you can sort out all your coding problems within your testing environment. You can sort that out. Teams provide poor documentation. Um, that counts against them. This is the easy part where you can score a lot of marks quite easily that can move you up the ranks. Unstable vehicle platforms. I've already mentioned that in the past competitions, if your platform is not stable, you're going to experience a lot of problems at the competition, and you do not want to design, test at the competition. That's where you only need to apply and make sure that it works. Um, Again, another common mistake is I've seen it at so many competitions where teams arrive at the competition, then they start testing their robots. That needs to be done before the competition. Make sure that your robot works well when you go to the competition. Strong teams do well. They have got robust designs, simple designs. Keep it simple and make sure that it can do the job. A lot of teams adds the bells and the whistles before the robot can actually do anything on the track. So keep it simple. Make sure that it can do the job before you move on. They test their robots under a number of different conditions. They make sure that it can do the open challenge, it can do the obstacle challenge, but they keep on testing it and moving the obstacles around in different combinations on the board. So keep on testing. That is really important. They use clear engineering reasoning. They analyze what they're doing. They have a look at Can they motivate every step that they are doing? So if you ask them a question about what the vehicle is doing, they can spend hours explaining what they've been doing. Then there are the teams that are not performing well. They can hardly explain what the robot can do. Teams that do well have got really good documentation as well. A couple of updates to the 2020-60 rules. This year, we're probably going to exercise and implement the surprise rule. We've strengthened the documentation evaluation. There's a new rubric that we've created, which is a lot more easier to follow. And if you follow exactly the rubric that we're providing, you will get good marks for your documentation. Bonus points are only awarded after completing a full round in the competition. Clarifications in scoring and procedures, we spend a lot more time on updating how we do the scoring and the procedures at the competition, how we're going to do that. How to get started? Read the official rule book carefully. Start with a simple vehicle platform before you start adding the bells and the whistles. Test frequently. Get an area where you can do your practicing and practice frequently on that track. And then while you're working on it, for every decision that you're making, if you change something, document it, because that you need to present to the judges. For new teams, what are the advice I can give you? Start simple and slowly improve gradually. Focus on reliability rather than the speed of your robot. There's so many teams that try to do it as fast as possible, but they cannot do it reliably. They cannot do the same test 3 or 4 times in a row and get more or less the same results. Don't go for speed first. Go for controllability and reliability, rather. Test your robot in different conditions. I've already mentioned that. Really, really important. Work as a team. And then, I've said it so many times, document your progress. A final message is Future Engineers is about engineering thinking. It build a system that are reliable and adaptable. A lot of different systems. One robot can include many different systems, so make sure that all of them are reliable and adaptable. Learn from testing and iteration, but I would like to add in here is learn from previous year's teams as well. Go onto YouTube, watch the videos of previous year's competitions, watch what the people are doing, and learn from that. Most importantly, you need to enjoy the challenge. Ladies and gentlemen, that is it from my side. Duncan, then I'll pass it back to you. Thank you, Duncan.
Thank you, Johan. That is really amazing. I myself have always been mystified by the Future Engineers category. It's an incredible thing to see up close and personal. So if it's something that interests you, I'm very happy Johan was mentioning it. It's all about the next webinar. I'm going to be working with Johan and Tony as well, so our RoboSports expert, and I want to get a whole chain of different videos on starting with Future Engineers and RoboMission to build the knowledge base in South Africa for these two categories and build up the participation in those categories, because I think having our experts like Johan and Tony explaining these categories to us to demystify them is really, really important, and something that I would love to see not only here in South Africa but internationally as well. So thank you, Johan, for all of the Future Engineers information. I'm looking forward to the next webinar. We'll be releasing that information soon, probably in a week or two, and I hope that you listening have learned something about this incredible category and that you're actually fired up to get started. I'm quite excited. I think I might run outside and find a team somewhere and get my own challenge going with the Future Engineers team. So thank you very much, Johan. That was really informative and really, really great. Thank you. So I missed a little bit here. I want to just say thank you to Resolute Robotics or Resolute Education for sponsoring the World Robot Olympiad in South Africa here. It is amazing to have such a good sponsor. They are here for us all the time, and we are very happy to have them. So I will be running over the in-house challenge. So the in-house challenge is a really fun thing to get started with and involved with. And what is the in-house challenge? Or first up, why the in-house challenge? Well, first, it is not a competition. It's a challenge. So what do I mean by that? Well, For the in-house, we are looking at the kids challenging themselves. You're not going up against someone. There is no winner for the in-house category. You can only do the best that you can using your robots and your love for robotics. So it's really a test against yourself. So don't worry, there's no pressure. You're not competing against anyone. You're welcome to make a competition in your schools or in your clubs between your teams, but it is just a challenge. There is no winner in the in-house. It's for the love of robotics and for the love of problem solving. It's also been designed in such a way that it is easy, it's fun, it's exciting, engaging, and it's most importantly manageable for you as a coach. So it's something that you can pick up and run with, whether you've got years of robotics experience or if you just started robotics last week. It's something designed for anyone and everyone to just enjoy this incredible world of robotics. We put an emphasis on doing the best that you possibly can. It's all about trying, failing, trying again, succeeding, and trying to up yourself each time. It's all about enjoyment, having fun, and most importantly, really loving this world of robotics that we found ourselves in. We also implemented because we noticed that not only in South Africa, but around the world, once the provincial competitions or regional competitions have ended, not all teams are going to go through to the national final. And what tends to happen is a lot of teams tend to drop off and they lose interest in robotics. We've introduced the in-house to combat that and offer it as a way that you can keep doing robotics right up until November. So you can keep running with a robotics program right up until November. So even if your teams don't make it through to the provincial competition or the national competitions, in-house is a competition you can still compete in right up until November. So what is it? Well, it's a South African created challenge. It's run by us here in South Africa. Other countries are running their own ones as well, and some even get involved with ours. We do have, I believe, some teams from India this year that are going to compete in our in-house challenge. It's run by you, the coach, or you, the parent, in your own club, school, home, wherever you are. You run the in-house challenge in your own environment. That means there's no travel whatsoever. It's in your own club or lab. So it's somewhere familiar, not only for you and your kids, but it also means you're going to be running your robot in your perfect conditions. Your robots are used to running on your tables, so you have an advantage, and they will run wonderfully in your labs. It's designed in such a way that anyone can participate. Again, whether you've been doing robotics for a week or you have many years of experience, you can do the in-house challenges. There are 3 different challenge levels. We have an easy challenge, a medium challenge, and a difficult challenge. So level 1 is your starter challenge. That's for anyone who's brand new to robotics and wanting to test themselves. Level 2, you need a little bit more knowledge, and level 3, you need quite a bit more on the mechanical side than the coding side, knowledge-wise. Now, you can do any of these challenges. You can start with level 3 and work your way backwards down to 1, or you can start with level 1 and go all the way up to level 3. You can do one of these challenges. You don't have to do all of them. It's up to you as a coach to decide which challenges or levels you want your teams to do and which ones they'll be available to them. There is only one age group for the in-house. It is suggested to run between the ages of 6 to 19. However, any age can participate in this challenge. We are not very strict with it. So if you have a 50-year-old who wants to compete, you are welcome to compete in the in-house and get your in-house certificate. We are not worried at all because, again, the in-house is created for the love of robotics. So how does it work? What you do is you select which challenge level or challenges you will compete in, and you can adapt these challenges for your needs. So for example, If you haven't taught your teams how to use an ultrasonic sensor and it's one of the elements that needs to be scored, you leave it out, give your teams those points, and make the challenge yours. Perhaps some of the elements that you have are too big, or you're seeing that your teams are struggling. You want to make the challenge easier. Go right ahead, change the challenge as much as you like to assist your teams and to assist yourself. On the other hand, if you see that it's too easy and too simple, make it more difficult. So if you have teams that are doing robo mission as an example, and you find that the in-house is too simple for them, that is perfectly fine. Make the challenge as easy or as difficult as you like, as long as you stick with the 330-point scoring system. So you can only send a maximum of 330 points to our scoring system. On that, you don't even have to run the in-house challenge for this year. You could run any challenge you like and submit for scores. It's all about the love of robotics. With it, you can run your challenge when you like. So during the year, you can decide when you would like to run your challenges. The rules were released in March, and the final rule set for level 3 were released here in April. So you can choose when you would like to run. So for example, let's say that you've just started with robotics. I'm going to run level 1 next week with my teams, and then 3 weeks later I'll run level 2, and then 3 weeks after that I'm going to run level 3. What you do is you save your scores, keep them somewhere safe, and when the registration system opens, you then submit your scores. And you submit your scores through to the World Robot Olympiad website between the 1st and 31st of October, and you will receive a digital certificate. We're only looking for the scores, so please only send us the scores when the score sheets go out. We don't require any recordings of your robots moving. We don't need a score sheet of your robot doing anything. We only require the full scores, because remember, in-house is about having fun, and it's about learning and continuing robotics in a fun way. So what are the challenges? Well, here is level 1, and this is level 1. It is called the Research Ready, and you need to collect various elements on these mats and take them to different locations. We have debris. These are these 2 yellow blocks down there, and they need to go to the start area. You then need to deliver a toolbox that is situated right next to the start area, just over there, and it needs to go to the excavation area to help the paleontologists dig up the dinosaur fossil, so straight to the dig site. Then you need to collect and deliver 2 pallets to the storage shed. You've got pallet 1 positioned over there and pallet 2 positioned there. They need to be delivered to this large storage shed area. We have our dig site fossil, that's the white piece down there, and that must not be moved or damaged. It's embedded in rock. It's quite delicate, so please don't let your robot touch that. Then your robot, when it's finished, your team must touch the robot, say stop, and end the program. They will score some simple points for that. And last but not least, you have these 2 wonderful pieces here, these green elements. These are ancient pillars. Think of Roman or Greek pillars. They like those kinds of things. So we've got 2 pillars on the game mat. They must not be moved or damaged. And that is it for level 1. Nothing too crazy. Jumping on to level 2. Again, you can start with any level you like. So starting with level 2, again, we have debris. This time they've changed position, and they need to be delivered to the sifting shed. There's valuable paleontological material in there that needs to be sifted through, just in case you find another fossil. Now, speaking about that, look at what happened here. The paleontologists found a fossil there, and it is now needing to be taken from the sifting shed up to the storage shed. So your robot will have to pick that piece up, carry it across the mat, and put it safely into the storage shed. You then have 2 elements on the game mat that are for building the research tent, and they need to be taken from their areas down to the research tent area. You then have an artifact on the game mat, that's the white piece up the top here, and that also needs to be taken through to the storage shed. Can you believe it? Nice and easy. Finally, we have our dig site fossil, and once again, it must not be moved or damaged. It must stay exactly where it is. Do not damage our beautiful fossil. And we have our pillars staying in their area. That's where they must stay, mustn't be touched. And last but not least, because the dig site is getting quite deep and it's quite dangerous now, we need to deliver 2 guardrails, these blue elements over here, down into the dig site area. And that is it for level 2. Now jumping to level 3, the research tent has moved from its start area over there into this new area down here. And again, we must collect debris. So the debris starts in the same way as it did in level 2 and must go to the sifting shed. You then have a black monolith that's arrived on the beaches nearby, and that needs to be taken up through into the storage shed and placed so that it is touching the black square in the storage shed. We then have a pillar that's been excavated, it's fallen over, and your robot needs to lift it up and push it back into position. Then we have our dig site fossil. So finally, the paleontologists have dug around our fossil and it is now ready to be moved. You'll collect your dig site fossil and take it through to the research tent. With that, the fossil we brought back to the storage area in level 2 has finally been identified. And wouldn't you know it, it's part of the same dinosaur. It needs to be taken also to the research tent so that it can be studied with the fossil that's been excavated. Then we have our pillars. Once again, our green pillars must not be moved. They must remain where they are. The research tent must stay where it is and not be moved. And last but not least, we have our guardrails, which have been positioned on the outside of the dig site. Those must remain where they started. So they cannot be moved or pushed around. They have to stay there. And that is it for level 3. So what do you need to get started with this challenge or in the in-house? You will need the game mat. We're using the Heritage Heroes game mat, the RoboMission Junior game mat. So if you are out there and you have RoboMission teams, you already have the mat, you already have the element box 45811 or the new element set which arrived in our offices this month. It is up there as well, and that's all that you need to compete in the in-house. You can use any robot you like, any software you like, and if you really want, you can also use a virtual robot as well. You do not have to use a physical robot to do these challenges. So where do we get our equipment? All of the equipment can be purchased through Hands-On Technologies. Send them an email at info@handsontech.co.za and ask them for the stuff for in-house, what elements you need for in-house. Not only that, if you're looking for things for Future Engineers, if you're looking for things for RoboSports or for RoboMission, Future Innovators, whatever kind of robotics equipment you're looking for, Hands-On Tech will most likely have it. So what are the costs for competing in the WRO in-house challenge? Well, all other categories have a cost of 350 Rand per team member. That includes our Future Engineers, RoboSports, Future Innovators, RoboMission, and Explorer. That's 350 Rand per team member. It's teams of 2 to 3, and that's 700 Rand for a team of 2, 1,050 Rand for a team of 3. Now, in-house, by contrast, is 350 Rand for your entire school or club. It's a single payment of 350 for an unlimited amount of teams. So if you've got 1,000 kids in your school and you want every single one of them to do the in-house challenge, they can for the incredible price of 350 Rand for everybody. Nice and simple. And in-house as well has teams of 1 up to 3. So if you have a team of 1, you're by yourself, you can still enter the in-house challenge. Registration for the in-house will open on the 8th of June and it closes on the 30th of September. So make sure you register in time, pay your registration fee, and in October when the registration system opens, or when the scoring system opens I should say, you'll be able to submit your scores and receive your team certificates for participating. So some contact information, if you are interested in anything WRO, please send an email to wro@handsontech.co.za or call our offices. You'll find all of our WRO information on our website. Now head to the South African website, please, if you are looking for specialized information, as well as the in-house or Explorer competitions. You won't find that on the international website. So our website is wrosa.co.za. That's where you will find all of the information. And importantly, please join the mailing list. We have a mailing list that has about 800 people on it right now. And if you join it, you will receive up-to-date information regarding WRO, as well as more information about any webinars going forward. So if you are interested in Future Engineers, you will be receiving an email about the Future Engineers webinars coming up. And now we get to everyone's favorite part, the Q&A. So this is your opportunity to ask your WRO questions. We are happy to answer anything WRO. We have Dani, our national organizer, with us, and he's been sitting in the chat answering some questions as we go. Johan is still here to help answer the Future Engineers questions. And what I'm going to do is I'm going to enable the ability for you to unmute yourselves, so you are able to unmute yourself and ask a question. I do see we have some questions in the chat, and we'll start with those before we get to anything else. So this is recorded. We will be posting the recording later, and you'll be able to watch it on YouTube. So please, if you've missed anything or you want to re-watch something, you are welcome to find it on YouTube. You can jump to our website. You'll find a link to the videos right there, the same place that you registered for the webinars. Now, I see that we have a question for Johan here. It's in the chat. Is passing the traffic lights always the same in each round? Johan, will it be the same in each round, left and right?
Duncan, no. It's in each lap, it will be the same, but in every round, we do a randomization before the round. So the placement of the traffic lights is going to be randomized, but a red light, you always have to pass it on the right-hand side. A green light or a green traffic light, you have to pass on the left-hand side. So that means passing the traffic lights are always going to be the same, but the position might be changing.
Great, thank you, Johan. That helps to answer that question. Then another one, and this is again, I think, directed at you. Do you lose any points if the robot is copied from designs on the internet? So watching the YouTube videos, will you lose any points if your robot's the same as another one?
You're not going to be losing points, but you might not be given the opportunity to participate in the competition. Part of what we do with this competition is we would like to promote innovation and creativity. So when you watch the robots or the videos on YouTube or on the internet, learn from them, but do not copy those robots, because then it is no longer your own design. We are looking for your own innovative and creative designs. So are you going to lose points? You might not lose points, but you might be disqualified from the competition. Thank you, Duncan.
Thank you, Johan. And that's the same for RoboMission as well. So if you have a robot and you've got a team that you are worried about, their robot you think may be from an online solution, you're welcome to send the query to us and we can look it up and give you our advice. With that, do not copy robots from the internet. It doesn't help you at all, and teams will be disqualified both in Future Engineers and in RoboMission. Next question, does the website have the challenge information? Yes, you can find all of the challenge information on our website. Please be sure to head to the South African website, wrosa.co.za, and you will find all of the rule documents, the registration, the judge's registration, everything is there ready for you. Another question here, can we please get a link for a virtual robot? There are many virtual robotics platforms that you can use. There's VRT as one of them, just off the top of my head, but there are others as well. You need to find what's best for you and works best for you. So please, if you are looking for something, maybe you already have one, you are welcome to use it for in-house only. All other challenges require a physical robot. Another question here, from in-house, to move from one point of the mat to another, so the storage area, must you use the black line or road or any other way to reach the destination? Now, I love this question because I think it's a very important one. And this is not only for the in-house challenge. This goes for future engineers, RoboMission, RoboSports, in-house and Explorer. Your team, when they're on the table, can move the robot anywhere they like, however they like. They do not have to follow any lines that are on the mat. They can move anywhere, any direction they would like, unless it is specified in the rules. So for example, if the rules say follow a line, then you would have to follow a line at some point. However, your robot on these circumstances does not need to follow any line on the mat. They can just drive straight across everything, ignore it, and move from point A to point B. Another question there, what are the benefits of following a line? Well, if you follow a line, it's taking you directly to a location. It's generally along a safe route as well. Often when your robot leaves the surface or leaves the line or the road, it's heading into no man's land. And if you don't have sensors, you could get lost along the way. You could bump into some very important pillars that could fall down, and in-house, for example, and your robot program will change if it's not using sensors and following a line. If you follow a line, your robot will tend to be more precise as it moves around the mat and get to the locations you want it to get to. Johan, your feeling on the benefits of following a line?
Duncan, you're 100% correct with what you've just explained. Following in line, if I look at the future engineers, there are no lines to follow, but there are different colored lines in our environment. As I've mentioned before, you need to decide if your robot is going in one direction autonomously. You need to figure out whether you need to go clockwise or counterclockwise. And one of the ways to detect which direction you can go is by looking at the lines that are on the ground. An orange line might mean that you need to go counterclockwise. A blue line might mean that you need to go the other way around. So following a line, there are benefits, but you need to look at what is the competition about, and would it be any advantage to follow that line? Following a line, you might get more stable to your destination. It might be the shortest route that is there, but these are all things that you need to figure out that will become part of your strategy. Thanks, Duncan.
Thanks, Johan. That's always great to get another person's opinion about these things. And yeah, so follow a line when you can, if you want to. It's up to your team. So if your team is confident their robot can move through the space without following a line and using sensors, go for it. They will learn lessons as they go. Any other questions? You are welcome to unmute yourselves and ask away. Otherwise, we have hit 7 o'clock right on the dot, and I am happy to go ahead and end the webinar. Remember, if you do have any questions, you can always send them to wro@handsontech.co.za, and we'll be happy to answer them. We answer many questions every day. Yes.
Yes, sorry. Good evening. I just want to find out maybe an advice on how we can strengthen the building of robots. You know, we, from the teams that are supported by SPU, with regards to programming, it's not a problem, but we always go to the competition with just the simplest robot. And when there are obstacles, we always struggle with grabbers and all that. Where can we go and just learn? We don't have like engineers that can assist us maybe with the thinking, because we are from just pure IT. And the engineering part, we are seriously struggling. I've tried to look around for people who can assist. I'm not winning.
Thank you for the question. I think that is an excellent question. From my experience, the number one issue we have in the robotics world is really around engineering. I find that a lot of teams are able to code and code effectively, but they suffer when it comes to mechanical design and engineering design. Luckily, we have an incredible resource in WRO Learn. There is a free resource where you can jump on and see different things on WRO Learn around the different categories. It's freely available, and you can jump on there as a coach, you can jump on there as a team member, or you can jump on there as a judge and learn about the World Robot Olympiad. In WRO Learn, there are some resources for that. You can also find a lot of information through YouTube and just internet searches. There are a lot of videos on how to build a claw, how to build a lifting arm, how to move certain things. Everything is available online. It's about searching and finding it. I'm going to go to Dani and then I'll jump to Johan. Dani, you want to answer?
Yeah, sure. Yeah, incredible, and it's a good question because obviously, as Duncan has explained, but just to help you a little bit, and maybe, I mean, Duncan is saying there's lots of resources out there, and in fact, it's something I'd like to research. So perhaps if you would just pop an email to us at wro@handsontech.co.za asking the same question, then we could actually provide you with a few links to go and have a look at for structurally good building. Okay, so please send us that email.
Great. Thank you, Dani. Johan, your response.
Yes, Duncan. Many moons ago, when I was coaching teams to participate in WRO, one of the things that we did to strengthen our mechanical means of building a robot is to go and have a look at what Lego has done over the years. You can go onto Lego's website and you will find building instructions of almost any of the Technic models that Lego has manufactured over the years. Now, if you look at those models, they all include mechanisms that can move something. And that is what you're looking for, is go and have a look at how did they do that. There's a lot of pneumatic trucks. There's a lot of racing cars. There's a lot of bulldozers that's been built over the years. So go and have a look at how did they build that and try and duplicate that with the equipment that you've got available. And that is a good starting point to get to know and to play around with existing mechanisms. Thank you, Duncan.
Thank you, Johan. Thank you, Dani. Those are awesome answers there. I didn't even think about using the Lego resources for that, Johan. I'm going to use that in the future when teams ask me. That's an excellent, excellent idea. I see we have another question here about in-house. Must the robot have all the possible sensors on the driving base, or can we decide that during analyzing the task? So with in-house, you can build your robot however you like using whatever you like. So if you have 5 light sensors that you want to attach to it, you are more than welcome to attach to your robot. There's no set design for how your robot should be. There's no set base for how it should be. The only restriction, I believe, is the actual size of the robot. It has to fit inside of the start area. That is the only real restriction on your robot. You can use however many sensors you like. Remember, it's about doing robotics and having fun. So if you want to make it more difficult for your teams, you could remove sensors, you could limit sensors, you could limit the number of motors that they're allowed to use. If you want to get a certain learning across, perhaps you're teaching the light sensor, you could add a rule that they have to use the light sensor somewhere in the program or somewhere on the game mat, and that could be your bonus 30 points that you can award that team. It's all up to you and how you want to do it. And again, remember, with in-house, you can make it as easy or as difficult as you like. You can change the challenge and make it your own. Any other questions? Great. It doesn't look like there's anything else coming through. I want to say a big thank you to Johan and Dani for jumping into the webinar this evening. And thank you to all of you for sitting through everything, listening to these incredible 2 categories. And I look forward to setting up our next webinars with the Future Engineers webinar coming soon, as well as RoboSports. And for anyone interested in Future Engineers, that's going to be an incredible learning opportunity. However, our next webinar on our schedule, which will be posted soon, is going to be all about judging in WRO South Africa. And it will cover topics like why you should judge, how to judge, and what is required to be a good judge. If you are new to WRO, we highly recommend jumping in and learning to judge. Thank you, Johan. Thank you, Dani. I hope you have had a very great webinar this evening, and I wish all of you the best of luck with this year's challenge. Johan, I'll be in contact with you shortly about our Future Engineers webinars. Thank you, everyone. Have a wonderful evening.